So some time has passed. I'm now back on the LS101, which has got the blind regulator in the back here. The parts have arrived over here somewhere. It's one of these packets. So I've just started taking the thing apart. I've taken the IEEE board out just so I can get easy access into here. I've already taken the top screw out. It's like a nylon screw here. I have a driver which just got in there okay, and that's a 5.5mm, but the other one's behind the chassis here, so it's a bit awkward. So I used a spanner to get in there to get it loosened to get it started off. I'm now going to use some tweezers to get it out the rest of the way. So once I get this out, then I can desolder the regulator, take the whole thing off with the heatsink as well as one single unit. Then we can replace the part, put it back in again, and test, see what happens. Not the easiest thing to get into. It's certainly not the worst, but could be better. It's not loose enough yet. No, it's still going. Screwed in by a long way. Can't be much longer. Oh, come on. That must be out by, surely. There we go, it's out, just fell out. Yay! So there's a close-up where the holes are, and the heatsink, which is now a little bit wobbly because it's only reliant on the pins now to hold that thing in for the actual device. So you get in there with soldering iron, desolder all the pins at once. Probably I'll try and get some wick in there. Maybe I can get it wicked out. That will then come out as one piece, and I can put the new part on there, reverse the process, and we'll find out if it works. Well, I know it does work because I've already done a power supply substitution, so that should actually at least get that part working. And I can carry on with the rest of the repair. Put some extra flux on there to help get it going. We'll see if this will work. I might also have to put solder on there too, but we'll see. Hopefully it'll wick up with this, and hopefully it'll be alright. All the pins are still secured, nothing's wobbling. That's great. So, let's wiggle it out the other way. Let's do it the old fashioned way. Hit it up and wiggle it out. Wow, this is being stubborn. Even that's having trouble. So what I'll do now is I've put some fresh solder on there. We'll see if we can get out with that. Re-wick it with some fresh solder. Maybe it'll be enough to make it come off. We're trying to do this in shot at the same time. Well, it's moved. It's not out, but it's moved. It's not what I wanted. Nah, that's no good. Yeah. Be a pain. Well, I did the old technique of just flooding it with solder and heating the whole lot up at one go and gradually getting the thing out. Now I've got it stuck. There we go. There is the device. UA78MGUIC. I've got one of those over here somewhere. So I can replace that IC and just I've got to clean those holes out now, obviously try and get the bloody part back in. But I only got two because these things are fairly expensive. So hopefully nothing goes wrong. It's supposed to be new old stock. It's supposed to be. Looks fine. Looks very similar. Although not exactly the same. One's 1999, one's 1984. So yeah, that'd be why they look a little bit different. Different years. So all good. I should replace this part. Well, I've got the holes cleaned out. Took a bit of a mission, but you know, it's a bit awkward to get in there. But anyway, it's cleaned out. So now I'm going to do this part. And conveniently, that's also a 5.5mm nut. Look at that. There's no insulator and no thermal compound. I think I'll put a little bit of thermal compound on there just because I think it's a good idea. Yeah. So as far as alignment goes, get right away with it. I've got two ways of doing this. I can either leave it a little bit loose and put it in the chassis and try and tighten up in the chassis, or tighten up now and hope it will line up. I'm inclined to tighten up now and hope to line it up. Or set it in there. Yes, I can. Look at that. How's that for convenient? Right. What I want to do is hold the nut in place so it doesn't spin, and then do the screw. Alright. Nice and tight. Because I did put this in place just now and pushed it through the holes, and all the holes seem to line up. So it should be close, and I did have it fairly tight, but it's enough to still wobble around. So that can now go back in. I hope so anyway. Alright, let's try and drop that in. And then get it in place. Get those holes lined up. Then before I do any like soldering or anything like that, I'm going to put those 2 bolts back in again, those nylon bolts. That way it's definitely lined up. I'm not trying to stress anything when I'm trying to get it back together. And the problem is we'll get the bottom one in first, because, you know, why have it easy? I suppose I could put the top one in, get that lined up, then put the bottom one in. Oh, there you go. Dropped them now. That solved that problem, didn't it? Dropped the damn thing. Right. Yeah. This is going to be fiddly, isn't it? Shove that through there. Get the screwdriver, nut driver. Pop that in. Get this lined up. Come on. And of course it's just pushing the nut back into the driver, isn't it? Because, you know, that's always helpful. Until I get the thing started, it's going to be a pain. So yeah, I was going to get the top one in, use that as an alignment tool. Then I'll get the bottom one in. And probably you have to take the top one back out again. There we go. I don't know how strong these little bolts are either. I do have some old Nylock, well, some other Nylock bolts, but I don't have the right size. Well, not Nylock, they're nylon. Come on, get through the gap. Really? Don't be a pain. Come on. The gap is a bit smaller than the size of the bloody bolt, isn't it? Let's try grabbing it in the middle instead. And get it into the hole. No, that's going to spin. Of course it is. Come on. In the hole. Right, that's... No, it's not working either. Wow, this is a bit of a crappy design. Let's try and hold it there and spin it with another tweezer, which this one's not really suitable for anyway. Right, there we go. Let's swap over. Use that tweezer to hold it and this one to try and do it up. I don't think this is going to work. Anyway. Maybe I should have taken off the other bolt instead of the whole heat sink assembly. Come on, go in. It's just going everywhere apart from in. Once it starts, it'll be right. Oh, I think it started. Right. That appears to be screwing in. Right. I'm not going to bore you with this. I'm going to screw that in. I'll take the top one back out again, so I can align or tighten the bottom one up, because otherwise I can't get to it. So anyway, you get the idea, don't you? Then I'll solder that piece back in. Right, they're in. Now I can solder these bloody legs up. What a mission. Right, silver solder. And I'm going to try and do this without blocking the camera, but which is usually almost impossible. Especially when I see what I'm doing. Yeah, this isn't looking very promising actually. No, I can't do it like this. It's just too damn awkward. Right, this is about as much as I can tolerate. Okay. Now I'm blocking the light, of course. There you go. One more. We're nearly done. Something's bound to go horribly wrong any second. So I realised I put the thing in upside down. Something, I don't know. One last touch up just to make sure it all flowed nicely. That looks good. Pretty happy with those. What do you reckon? Look good? Cut those off. put the GPIB board back in again and we'll carry on. It's not looking too bad. Right, so I'm almost finished putting the GPIB board back in again. Let's go put the screws back in. Then that can be counted as done. I've already connected it all back up again. Then we'll power it up and see if it actually works this time. Well, also I have to measure the voltages, make sure it's correctly set. Otherwise I could have a problem. It's got to be very precisely set. Actually I need to power up my multimeter so I can do the measurement properly. Both these units I picked up both had multiple faults, and that's not unsurprising. That's often the way. It's always a bit concerning though when you get a unit and it turns out it's been like a part swap unit and things aren't quite as good as they should be. I think the screws are tight. Post checking me once in a while. Right, so that's all back together. Those are hooked up. That's all good. Definitely okay there. I hope there's no other problems going on. Fairly confident. Let's plug power in. And I need to measure voltages on these test points. So I need to get my clip leads on these test points. Before I do anything else. Got two adjustments over here. Don't know which one's which. I'm going to have to look that up, I think. One is set, one is not. So that's that point there. This is the one we just installed. Just the one I need to check first, make sure it's not like really badly screwed up. Okay. Screwdriver in case I need to adjust it quickly. Ready to power up. So I've got the meter put on DC. I have now anyway. We'll power it up, see what happens. Oh, look at that, 14.98. Excellent. So which adjustments which? Just go for this one first. Yeah, that's not the right one. So I've changed the test points over to the analog board, which are the other test points which you actually do the calibration for, reference later on. I'm just going to double check the voltages I'm supposed to be at. This one is drifting once I set it, which I think is just the adjustment itself. I think it's just settling. So I'm going to double check the voltages while I'm waiting for that. I just reread the information. I was thinking about the 5.1 volt rail, which is 5.1. They should be 15 pretty much exactly. So let's tune this for 15. Let's check on these heat sinks. The negative one's slightly warmer than the positive one. They're both a little bit warm, not too bad. Wind this up a bit. Up is the other way. I'll try and get exactly 15. I'm nowhere near the centre point either. I mean, that's centre adjustment there. As it goes up to 15.9 max. So, got plenty of adjustment there. Really a multi-turn pot would have been a bit better on these. Being it's like a range reference supply used in all the op amps, it's quite important to get it consistent and stable. So multi-turn would have been better. Anyway. What tolerance did it say it could have? I've forgotten. I should go have a look at that too. Plus or minus 15 millivolts. So I can go 15.015. So that's fine, that's in tolerance there. That's okay. Let's do the negative rail. So that's a fraction low. We'll pop that one up a little bit. That one was a bit more touchy. Come on. Might be a bit dirty actually. Let's give it a bit of a wiggle around. Right. There you go. That'll do. Happy with that. And that's the voltage reading on the 5 volt rail. So a touch high, probably fine. Probably doesn't matter that much. It said plus or minus 25 millivolts, so that's only 8 millivolts above the set point, so that's well within spec. So that's fine. So that's the power supply rails done. So now we've done that, we should actually see if it's working. I don't remember where we got to with the other thing. I did that substitution test and it seemed to fix it. So let's just chuck in a voltage from, I don't know, we use this, and a cable. I'll grab one. Turn it on. So it's going to be DC volts. Shove that in there. I'll do a self-test soon too. Anyway, so we're getting 0 volts, U1, nothing, no voltages. Why are there no voltage readings? It's not on hold, is it? No. Let's do 10 volt range. So this is not reading very well at all. Look at that. Very, very slow to react. I'm not quite sure what's going on there, but it is doing something. That's giving a negative reading. That's not what I want, is it? 0? No, it's just floating. What's going on here? Is it the rear input thing? Something's wrong. No input. Is it the rear input switch? It might be the rear input switch. I might have knocked it. Hold on, let's try this again. 1 volt. Hey, there we go. Right. Bloody switch on the back. I knew that'd be a pain. Yes, I'm actually tempted to get the thing. I'm never going to use it. It's going to catch me out time and time again, I'm sure. Right. So 1 volt. 2 volts. Okay. It's working, but it's low. 3, 4, 5, 6, 7, 8, 9, and 10 volts. Right, it's actually doing something at least. Just out of calibration. If I zero that, is that going to matter? 1 volt. No, still way off. So, okay, calibration's way out of whack. Zero that one. Oh, 100 millivolts I'm looking for. Can't see that really, can you? So it's kind of there again, out of whack. 190. Yeah, calibration's way off. Okay. Well, I'm not even sure if it's got the original boards in it compared to, you know, like the other unit I had been board swapped. But this still had the battery in it, so I thought, well, okay, great, calibration data's probably still there, and I probably don't have to do too much. It would be nice to actually have a third-party calibration to do verification against. But unfortunately, this is so far out, there's no way this is correct. The 100 volt range, so that registered, yeah, 995. Do 10 volts on here, and yeah, 9.95. That's out by too much to be a calibration issue. Well, a difference in my calibration data compared to theirs. It's just completely wrong. So anyway, it's working. Let's do 1000 volt range. Is that registering? It is. So yeah, all those ranges are working. Excellent. Let's just check resistance. If I can figure out where I put the remote. Oh, it's under here. Right, let's try resistance. We've got this box here set up. Let's go to the resistance ranges. And let's chuck an auto scaling. I've got it zeroed, so what I might do is just do a input 0, and I go through each range and zero all of them. Oh, error 4. Calibration data is obviously so far out of whack it doesn't like it. So I guess you won't be doing that then. Okay. 1-2 resistance and local guarding, that's fine. So it says that, is it going to 0? No, it won't 0. Okay. So I can't zero that. Let's just at least check for, say, on 10 ohm range. Let's go up by 10 ohms. Yep, that worked. Let's go up by, say, 8 ohms and then do 18. Yep, that's fine. Okay, let's do 100 ohm scale. Let's do 105 because of that zeroing is completely out. That is so far out of whack, it's not funny. Yep, okay. Alright, and then do about 85 it should come up as, yep. Okay, so at least it's working. It's just a long way out of calibration. There could be some other physical adjustments. I haven't done any physical adjustments on this board. Obviously I've only just fixed the power supply, so I haven't gone anywhere. So these could all be in need of adjustment on this board here. It's actually quite likely someone's been in twiddling things. Any markings? Sometimes the pots are marked, but they're not marked this time. Okay, so let's do Oh, I was 1k and done 1k yet, have I? 1k, here we go, and about 1.8 or so. Yep. Let's do 10k. Yep, and about 18. Yep, that's looking alright. 100k. Yep, and about 180. Yep, that's looking good. And 1 meg, which this thing can't do. But I can do 900. There we go. Alright, so it looks like it's working. If I do a 10 meg range, yeah, that's there. So at least it looks like it's functional. Excellent. Don't forget to like and subscribe, give us a thumbs up, you know, have a chat in the comments. I always forget to say that. Often. I forget to say at the beginning of the video. Yeah. Take the top one back out again, get the alignment tighten up, get the tightener. I'll take my top back. Oh bloody hell. Let's power it up. Ready? That's not right. Why is it not working? Oh, I'm on AC. Yeah. Cut a bit out.